Okay, thanks very much for the introduction. My name is Dr. Fionnuala Murphy and I'm an assistant professor in the School of Biosystems and Food Engineering. And today I'll be talking to you about achieving sustainability in food production. My research mainly focuses around using engineering principles to achieve sustainability. So essentially, understanding, quantifying and analysing complex environmental exchanges from technology development and implementation across the full value chain. So I've implemented this across renewable energy systems, and now I've got a significant focus within food production systems. I've attracted funding of over €5 million, which has enabled me to build a team of 7 PhD students, 5 master's students, and 2 postdoctoral researchers. So this team works across a number of different research projects. These research projects are really centered around achieving sustainable food production systems. So looking at nationally funded projects, generating additional value from agricultural wastes in agri-bio-circular economy. Similarly, in a European funded project, we're looking at the development of novel biorefineries for the production of added value products from whey, so a dairy byproduct. So that's really, I suppose, generating additional value from waste. And then also moving on into other areas where we're looking at developing novel food products and ensuring that we're doing that in a sustainable way. So within assessing the sustainability of different types of food production systems, there's no one-size-fits-all approach to applying life cycle assessment. It depends really on what the aim of the project is, what the goal of the project is. So for example, when looking at generating additional value from agri-food wastes, what you might want to determine is what are the environmental impacts of doing this. So if you're taking a product which is a waste, so it's either going to disposal or it's going to some other use, so it might necessarily be waste, it could be a co-product. So if we're taking that waste from its original use, then it's going to have a knock-on impact. So we'd utilize what would be called consequential life cycle assessment in this sort of research. So I apply consequential life cycle assessment in my work on ABC economy and also agrichem whey. So really looking at what are the impacts of making interventions, taking a waste and generating value from it. So then going on to projects which would look at new processes for the production of novel food and feed products from feedstocks that haven't been used within these particular processes. What you might then be interested in is taking a different approach. So you could be taking pilot scale data and you might need to scale that up. So to mimic an industrial scale facility so that you can show the environmental impacts or potential future environmental impacts of these new production systems. So these sort of approaches would be applied in my projects Agrifine and Spiral G, which are looking at the development of new novel feeds, essentially. And then you could be looking at more standard LCA work. So this would be looking at reducing environmental impacts from conventional food production. So taking an attributional life cycle assessment approach, looking at the interventions you can make towards making a food system more sustainable. And those sort of interventions I'd be applying in Farm Zero C. So we'll talk a bit more about these projects over the course of the presentation. The first example I'd like to talk about is the ABC Economy project. So this is a nationally funded project funded by the Department of Agriculture, Food and the Marine and the Sustainable Energy Authority of Ireland. So in this project, we're looking at Monaghan and Tipperary, mapping biomass resources, so agricultural wastes and co-products, and determining what value we can get from those resources. So this particular example focuses on poultry waste in Monaghan. So one of my PhD students, Kira Bosheim, recently published a paper on consequential life cycle assessment of anaerobic digestion. So she identified in the coming years, there'll be additional poultry facilities built, and those poultry that are housed in those poultry houses will generate 20,000 tonnes of poultry litter. So she wanted to look at the difference between the status quo, which would be land spreading of that poultry litter, or what we can achieve if we can implement anaerobic digestion to produce biogas. So from that 20,000 tonnes of poultry litter, you can produce 5.5 million metric tonnes of biogas. And you can either upgrade that to biomethane, and inject it into the gas grid, or you can use the biogas in combined heat and power. So you'd be displacing electricity and heat on site at that point. So these are just some results of the study. So the graph on the top there shows the global warming potential in a range of different scenarios that Kira analysed. So you can see the baseline scenario there. That's if we take the poultry litter, we produce biogas, and then we combust in a combined heat and power plant. We're then able to avoid electricity. And we modelled that we can avoid electricity based on the national grid. So this gives a benefit to the system. We're displacing the electrical grid mix by bio-based electricity. So this gives a benefit to the system. We can also see that there's some avoided peat moss as well. So this is considering the digestate produced from the digester can be utilised in mushroom production. And then essentially it becomes a circular economy and we can displace peat moss. So that gives an environmental benefit to the system. But you can see then there's also environmental burdens. So the purple section there, so that's incurred fertiliser production. So that's acknowledging that if we take the poultry litter away from land spreading, then we must replace that nutrient input with something else. So we've assumed that it's going to be traditional fertiliser, synthetic fertiliser production. So that's a negative as well. And then we've also included the fugitive emissions from the digester too. So on balance, what we found was overall, you can achieve savings of almost 6,000 tonnes of carbon dioxide equivalent annually when you're taking 20,000 tonnes of poultry litter and treating it in an anaerobic digester rather than land spreading it. So this is just highlighting the environmental benefits of taking food waste or agri-food waste and generating additional value from it. So that's taking the consequential LCA approach. So the next LCA approach that I'd apply would be looking at these new developing processes for production of novel food and feed from alternative feedstocks. So the projects I'm going to talk about here are the AgriFine project and the Life Farm for More project. So the AgriFine Marie Curie Innovative Training Network project is a training network of 15 PhD students employed across Europe in European universities and also in industry as well. So there's significant industry focus to the network. And the research aim then of this project is to develop a novel 3-phase bioreactor, which is monitored and controlled by a biosensor. So this allows us to develop a whole range of high-value products, a cascade of products going from high value to low value. So high-value lactic acid to lower value digestate and biogas from feedstocks that are, I suppose, having a novel use in this system. So taking grass in a biorefinery and also taking seaweed in a biorefinery. So we're using feedstocks that are being taken away from their traditional use and applying them in a new biorefinery. So the novelty here is really around the biosensors and how we can integrate that in life cycle assessment. So in the Life Farm for More project, it's a similar project to the Marie Curie ITN project, the AgriFine project, but it's more of an implementation project. So actually implementing the biorefinery. And again, the biosensors are key here in the monitoring and control of the system. So what we're developing in this system is a life cycle assessment method which can provide real-time assessment of the environmental impacts of the system. So you can see in the middle of the circle here, you can see the location of the biosensors in and around the downstream processing. So we can take data obtained by the biosensor at that point, and we can predict where or what products are going to be generated based on the quality of the feedstock into the biorefinery. And that in turn then will determine the environmental impacts of the system. So this novel real-time LCA method is being applied in this project, AgriFine and Life Farm for More. And it's an ongoing development in that we're complementing this biosensor LCA or real-time LCA with also other opportunities to monitor supply chains and feed that into LCA as well. And then the third type of project that I'm working on is looking at conventional food production. and looking at how we can make that production more sustainable. So the example here would be the SFI Future Innovators Project, Farm Zero C. So I'm also a funded investigator in BioOrbic. So I'm collaborating with a number of partners across Ireland and across Europe as well on this project, where we're looking to develop a carbon neutral resilient dairy farm. So working with Carberry on this, with the Shinock farm in West Cork, taking that farm as a case study. We're measuring the carbon footprint of the farm. We have data on that already. So the current carbon footprint, it's already better than the national baseline. And then we're looking at ways that we can bring that carbon footprint down. So producing a carbon neutral dairy farm by 2024. So we can enhance the sustainability of Irish dairy production. So some of the interventions we're implementing here in this project. So we're looking at soil and grassland. So looking at implementing and planting multi-species swords. So this will essentially allow for the reduced use of fertilizer. Because if we're talking about any agricultural system and life cycle assessment and assessment of the environmental impacts of the systems, often you see significant impacts from the fertilizer. So the utilization of the multi-species swords can reduce that fertilizer input and bring about environmental benefits. So that trial has just been carried out, and happy to say that the results are good and the cows are very happy with the swords. So that's a positive result so far. We're also looking then at a key part, which would be the animal diet and reducing greenhouse gas emissions related to, I suppose, belching. So what we're doing there is looking at trialing feeding of different types of seaweed to reduce greenhouse gas emissions there. That research is ongoing at the moment. And then we're also looking at the farm infrastructure to see, can we implement renewable energy? So for example, there's already a wind turbine on site, but can we implement or install further wind turbines and link them into the national grid and feed renewable electricity into the grid coming directly from the farm? And then also looking at the farm buildings to see, can we implement solar PV systems as well to provide more renewable electricity to provide for the farm's electricity needs and then also feeding into the grid. And then one of the very important aspects of the project, so not necessarily related to greenhouse gas emissions and becoming carbon neutral, but towards becoming more sustainable, is the inclusion of biodiversity. So looking at maintaining biodiversity and increasing biodiversity on the farm. So in this situation, we're enhancing ecosystem services. There's a lot of attention on this at the moment, and it's one of the key things we need to do to achieve sustainability in farming. So taking all these interventions together and then applying life cycle assessment, we'll be showing that over time we will be able to achieve a net carbon dairy farm. And hopefully this will enhance the sustainability of dairy production in Ireland. So thank you very much for your attention. I hope that I've given you an overview of how LCA, life cycle assessment, can be applied across different food production systems depending on the goal of the research and how we can use it to really enhance sustainability of food production. Thanks very much.